Well, hello everyone, it's Nono here, and we're gonna get started really soon. Hi everyone, it's Nono here, and I want to welcome you to one more week of this live stream. So this is the Nono.ma live stream. We're going to cover, as always, topics that have to do with creative coding, machine learning, art and design, and many more things. For those of you who are new, I'm Nono Martinez Alonso, and this is a weekly spot in which I code in front of you in the hopes of learning myself and also trying to help you learn as well. Today, we're gonna have a main central topic that is StyleGAN that we'll discuss later, and I'm just going to give a few seconds to more people to come and join, and we'll get started really soon. I want to say hello to Jose Luis, see some familiar faces on the stream right now, and let's see if this works. Awesome. So this live stream is, there are some questions. There's a question about whether the things that we see are a bit too advanced for some intro programmers or beginners. We'll also talk about that in a second. I just want to say hi to everyone. Thanks for joining us. And yeah, let's get started. All right. I would ask you to like the video if you want to support the channel, because that's the best way for other people to get to know these videos and the work that I'm doing here with the live stream, and also the work that you're putting into being there and collaborating with the channel. And if you want to get notified when I upload new videos or when I go live next, you should subscribe. You can join us on the Discord community. There is a set of people that are already joined, and people are sharing their own projects, their own work, discussing things that have to do with machine learning, with design, with many things. Join us there if you're interested, and join the community. The link invite is at nono.ma/discord. And just as a recap, the work that we're gonna do today is a follow-up of last week. It ended up being time to refactor a StyleGAN Colab notebook. I have to admit, it's an intense notebook. It has a lot of code from the NVIDIA machine learning network, and it's really hard to understand, but I'm just trying to make it easy to configure it for your own needs. Today, hopefully, we're gonna jump into training, and hopefully, this is actually out of date. So this is from last week. This is not what we're gonna do today. You can see that video at nono.ma/live/23, and I'm trying to use that same nomenclature for every video. So this is live 23, so today is live 24. You can access this video at nono.ma/live/24, and that goes for any other videos. A reference to live 18 is that we saw for the first time some of these models that had trained with sketches and portraits of StyleGAN, really cool. I think in this video we tested it as well with a runway, if I'm not wrong. And so that I will encourage you to check that video if you want to learn a bit more of the basics of that. Let me take a look at the chat quickly here. I can see, as I mentioned before, Jose Luis has joined us. So this is Jose Luis García El Castillo. And also I see here Kiran Goya. I hope that I'm pronouncing your name right. I want to welcome you to the channel. I don't think I've seen your face around yet, but I want to say hello, and maybe you can tell us where you're connecting from, how you find the channel, and what you're looking for here. Also, as something that we're going to discuss later, your level of expertise in the terms or in the field of machine learning and programming. Continuing with the slides that I had for today, Live 22 is where we covered CVAT and doing object detection labeling, so labeling your own data set. That's Live 22. And shout out to a new episode of the Getting Simple podcast that I released last week. That's mini retirements. That was from a question submitted by Mark Exposito, one of our listeners and a friend of mine. And it's also a small essay on my sketches blog. So you can listen to this at gettingsimple.com/44. All right, what are we going to see today? So we're going to get our hands dirty as in every live stream. And the topics that I have for today are training StyleGAN, seeing how to generate images, hopefully do a bit of refactoring there to clean up the notebook part that generates images using a StyleGAN model, might be pre-trained or something that you're training on the moment. And then questions. We're going to actually see questions first, and I'm going to comment this maybe today and in future videos as well, and I'll let you know why this is. All right, so for the podcast, so for the Getting Simple podcast, I've been offering for you or for anyone who's interested on the podcast or in this live stream or on topics that I might have any answers for, right? If you ask me a question I don't know how to answer, that's going to be a bit useless, but I'll try. You can submit a question to me. So this is a voice note that you record online with this interface. If you go to gettingsimple.com/ask. Getting Simple and this live stream are kind of intertwined. They're like two different projects, but you can go send voice notes there. Some people, of course, will send voice notes there to ask me questions about the live stream, which probably I won't post on the Getting Simple podcast, but here on the live stream. And I encourage you to ask me anything. Ask me anything that you feel that might be good for you to know my point of view in a future episode or in a future live stream, or things that might help other people as well learn or see some aspect of our lives differently. If you submit a question regarding topics that I cover on the podcast, I might do an episode or answer your question as part of an episode in the Getting Simple podcast. If the question is more related to the live stream, we will answer it here. I'll try to answer it live as well. And this is what we're going to do today. So I've done similar things before, but this is the first time I think that I get one of the questions from gettingsimple.com/ask and put it here. I have one from Major Mystery as well that I haven't put anywhere yet. And, I have it there, and maybe we can also put that in the future. And I also want to say hi to Sajay Kumarji. It's one of the faithful attendees to these classes or these live lectures or live streams. So I want to thank you for being there and welcome you today. All right, so let's listen to Sutevas's question. I know that he pronounces his name on the audio, so you might be better off listening to it here. And, as always, would like to confirm from you that you can hear me okay, that you can see me okay, that there is no lag, and that everything is working fine. All right, let's listen to a question by Sutevas.
Hello, Nono. My name is Sutivius, and I'm connected from China. And first of all, I want to thank you for your work that you put on YouTube and your podcast. I found it's really interesting. And I have two questions for you. The first question is, how many program language you are familiar with? And I watched your live on YouTube, and I found you pretty much know a lot of things. And I'm just start learning Python. Yeah, and I want to follow. Sometimes want to follow your live stream, but I found it quite hard. I sometimes lost every time. And the second question is, I think that would you like do a something that's simple or easy, beginner stuff? Yeah, I kind of can let the beginner newbie following you. Yeah, thank you. Thank you.
All right. So that was a question from Sutevas. I hope that's the right way of pronouncing it. And, I felt this doesn't really go with the Getting Simple podcast, but with this live stream. I sort of have to apologize in some way because even as an architecture student, I spent many years coding even before I started studying architecture. And I've gone through learning many different programming languages. Of course, like, it's not programming, but I started with HTML and CSS and a bit of JavaScript, I guess. And then I started using PHP and learn object-oriented programming via Java, right? Not JavaScript, but Java. And then I don't really know what else I did, but I quickly started learning Objective-C because I wanted to get applications done for the iPhone and for iOS. And that's one of the first actual products that I put online before or after websites. So I have to say I'm a bit biased. I've gone through many years of programming. I can say I started programming in 2004 or 2002 or 2003. I don't know, maybe like more seriously in 2008 or 2006, 2007. And I've been formalizing it more and more. The thing of this is that afterwards I've learned many other languages, had to do with Python, Swift, TypeScript, C#, and I don't know, like a bit of C++. I don't know a lot of C++. I've learned Golang, touched a bit of Ruby, but don't know a lot. And probably more that I'm forgetting right now. So this doesn't mean that if you're a beginner, if you're starting, you should learn all these programming languages, but that after you learn a couple programming languages, or at least one pretty well, you can transfer some of the knowledge to other languages. And that's not going to work for everything. Of course, there's like different patterns and different ways of doing the same things in many different programming languages. But the overall or the underlying high-level concepts are going to be really similar, even though afterwards every programming language has a completely different way of doing the same things. I don't recommend anyone to necessarily have to learn many different programming languages, but start with one and try to get as good as you can. And Python is a really good one to start with, even though I would probably recommend a strongly typed language from the beginning. I think strongly typed means that you need to define the type of each of the variables that you're defining. So a variable being like a thing on computers that holds a value, right? So if you say, I want to store a name, let's say Nono or Kiran, right? That name will be stored in a piece of memory. In a language that is not strongly typed like JavaScript, you can assign a string, something that is text, to a variable, and then later replace the value of that variable with a number, and then later with an array or a list of things, right? So you can mix and match things. In something typed like Objective-C or C#, you have a defined type, and that's like the strongly typed part. And you have to say, okay, this name variable is a string, so it's only going to contain string characters. And you set that to Nono, and then you can change it to Kiran. But if you want to set it later to 23 as a number, that's going to fail. It's going to make your program crash if you don't handle the error properly. So what this does is that by learning a program like C# first instead of Python, you know that the variable types exist. You learn which ones they are: Boolean, string, float, integer, array, list, and many of these things. The other way around, it doesn't happen the same way. You get used to assigning arrays and then names and then integers to different things or variables. And then, it's harder to go from one place to the other. I feel it's easier to go from C# to Python, for instance, than from Python or JavaScript to C#. But I don't know. That's what I think. So that's for learning many programming languages. I think you'll be safe if you learn only Python as well in machine learning and many of these things. And JavaScript is also used in many places nowadays. Even though if you're going to do anything serious in JavaScript, I'll recommend TypeScript because it's like a superset or like a different language that helps you or lets you program with something that's going to run in JavaScript, but with typings, with defined types for the variables and the objects that you use. And then for the second part of the question, which was, I get lost all the time. Would you consider doing something more for beginners? I guess that's something that you guys have to tell me. And, that you guys have to tell me, and I need to know from you what things you'd like to learn that are basic. I know that some of you guys have told me when I was going through basics of how you program websites in JavaScript or how you debug JavaScript or HTML websites, that you said like, oh wow, I didn't know this, I really enjoyed learning this. And I'm really happy to start from the beginning in many things or many in many ways of doing things in programming or design. So you tell me. And one thought that I had was that we could add like an introductory section or like a set of tutorials at the beginning that cover more beginner like or basics things that maybe for people who are new to the channel can join and watch, and then maybe a separate live stream or on the same stream but at the end we try to cover things that are a bit more advanced. I don't know, that you tell me if that works for you or if that's something that you would consider that would be good. And yeah, so I am considering doing things that are more beginner or newbie level entry point. So it's just that I haven't had that much time to prepare these live streams lately, and we just had to do with the things that I could do. All right, so I'm reading here on the chat. So we have a message from Kieran, says, hi, Kieran is good enough. All right, so I'll stick with that. Although this is my first time attending your live, I've been following your work since the guest lecture from Jose Luis's Intro to Computational Design class in 2019. Wow, that's awesome. And thanks, Jose Luis, for the invite. Great work. Love your podcast. Especially enjoyed Jose Luis's. Now I'm here to stay and follow along. Machine learning is the one among others that I'm most interested to learn from this channel. All right, so you're in the right place. Machine learning is also the top thing that I'm looking forward to learning more about lately. And we have a question here from Sujay Kumarji. So I've been doing this. Do you have, so because Sujay asked another question a while ago, I have this profile here, and we're gonna put it here. So what's a collection of languages programming languages, I guess, that you recommend for a designer/architect, for designers and architects, to learn or familiarize with, to help with their work? All right, so let's just make this a video as well. And, you tell me if this is helpful or not, but I'll try. I wanted to do a Q&A session today. All right, let's put this here. I'm going to do a quick intro to this video. And I guess I'll have to go to the right for Sujay not to be covered. Okay. Hi everyone, it's Nano here, and I'm gonna answer a question by Sujay Kumarji on the live stream. The question says, what's a collection of programming languages that you recommend for designers/architects to learn or familiarize with to help with their work? Well, this question is a bit hard. There is no one-fits-all solution, but as far as I've seen, it seems that many of the tools that designers and architects use let you script in some way or another with C# and Python. If we're talking about things like Rhino, Grasshopper, Dynamo, and maybe other products that let you create plugins for them, like Revit, for instance. If we're talking more about the scripting world, you can also use JavaScript. So JavaScript is a language that you can use to script plugins or small scripts in Adobe products, things like Photoshop or Illustrator, for instance. You can do automations or even InDesign. But you can also learn Swift, where you going to build native iOS or macOS apps, but that's probably not the best to learn there. I know that C# now has good compatibility with macOS as well, so there's the .NET standard allows C# programs to run natively on Mac, even though you don't have the WPF or like Windows I think presentation framework, I think, for like doing all this Windows and visual components that Windows is characterized by. But yeah, I would say C# and Python seem to be the standard for what most people are using. If you want to get more hardcore and maybe go and do like web stuff, modern web stuff, you can learn TypeScript. And personally, for me, for backend stuff, I'm usually use PHP. You can also use Go. You can also use JavaScript or TypeScript with Node.js. So, if you want to go into things like visual programming, maybe Grasshopper or Dynamo, you can use Python and C# safely. C# more for scripting and creating plugins or packages, and Python more for the side that has to do with like low-level scripting or like even machine learning. If you want to go towards the route of building web apps and websites and user interfaces with web technologies, TypeScript and JavaScript are the thing. You can use TypeScript, for instance, to build front-end components with React or Vue or jQuery, if that's what you're into. And on the backend, you could use Node.js with Express or something like that. So you will have a website that is served with Node.js on the backend, and then on the front end, you put HTML, CSS, and whatever framework you want to use. For example, React is one of them. And here I can see, yeah, okay. So I hope, Sajed, that this answered your question. Thanks so much for asking. And, I'll welcome more questions for today or for future streams. All right, so let me go back to our cover before we get started. And I'm really happy with this new cover that we have. I don't know, what do you think? So we have this cover while the stream is starting. I would be hiding here, right? But I can still talk. And then when we're ready to start, I can pop up in here. And then we click here and everything goes away. So once more. All right. So I can see here, this is new for me. Kiran Gola, this message is held for review. It just says, hi, Jose, show. Yeah, so it seems like I'm moderating the message or something like that. All right, so we have this slide here that we usually tend to go to. And yeah, one last call out. I would really encourage you to go there, gettingsimple.com/ask. Send me a voice note for the live stream or for the podcast. They're two different things, different topics, but I would be really happy to hear from you. I'd love to hear from you. And yeah, I'm waiting for your questions. So that is something that I'll invite you to do. All right, let's code. So we have these topics here. So we already covered the question section. That's what we just saw. We're going to go and train StyleGAN and then generate images. I'll give you some time to reflect or to put more questions or to say any thoughts that you have. I am going to use my new break slide and go for some water, and I'll be with you really, really briefly. Thanks for joining, and don't go anywhere. We'll be back in a second. Okay, we're back. Cool. All right, so finally, let's go and code. Okay, so last week, I'll point you once again to last week's video that it's on the channel. So here, and if you go to either here or to the live stream, you'll see live 23. Another thing that I will maybe play here, I think this is pretty short, and I'm just gonna share with you as well a teaser video that I've done compiling not some of the best moments, there's too many minutes to go through, but just some of the things that I found interesting for the channel. So there's this welcome video that newcomers will see when they come and they arrive to the channel from outside. All right, let's watch that really quickly. Hello, everyone. It's Nono here. Hi, everyone. It's Nono here, and I want to welcome you to my live stream. For newcomers, if this is the first time that you're watching or connecting to the live stream, my name is Nono Martinez Alonso, and this is the Nono.ma live stream. We are currently doing a series of machine learning videos and tutorials and hands-on coding sessions where we just look at algorithms and try to understand them and do creative coding with them. Train things, generate images, learn how to use frameworks such as TensorFlow or PyTorch, or tools like Runway and Loaf. We cover topics from creative coding to machine learning to art and design, podcasting, sketching, writing, many different things. Like the video to support the channel and support the work that I'm doing here with the live streams and with the tutorials. It really helps. And subscribe if you're new and you want to get notified when I go live next or when I upload new videos. I press N, I click here, and then I move. You can also join us in the community. So we have a Discord server at nono.ma/discord. And if you have coding questions, if you want to learn machine learning, if you want to be up to date with the live streams and with other things that we're doing, also with the Getting Simple podcast, that's the place to go. StyleGAN 2 is a model developed by NVIDIA. Hello everyone, it's Nono here. Today we're going to be talking about DigitalOcean and then this one, Pix2Pix model. Mouse app, TensorFlow.js on a browser tab, or the other animation. Feel free to reach out. I don't bite. Thanks a lot for watching, and I hopefully will see you here next week. Okay, how was that? I don't know. I needed to put something as an intro, and that's what we came out with. Okay, so thanks Sujay for letting me know that the camera was out of focus. So we're gonna get started now. Last week, if you go to the Discord server, so I'm gonna open this here. So we have, all right. So I want to welcome Kiran. I already told you hello, but I'm glad that you joined the channel. And we don't have special effects yet, like a sound or something, but I want to welcome you to the Discord community. All right, so if you go to live chat, so this is on the Discord server, we're going to go here and you can see that last time, so this is links and chat for live 22 and this is links for live 23. So now we're going to do here links for live 24, and this is a practice that I'm trying to do lately, where I share the things that we cover here. Last time we shared the public Google Colab notebook, and it doesn't really say what it is, but I'm gonna copy and open that, and so this is gonna be a StyleGAN 2 training Colab notebook. I think this is what it is, and we're just gonna put this here and we're gonna click on it. So I'm opening a Colab notebook that is open and public. The link is on the Discord server, and I will reiterate a bit. So the link is on the Discord server. You have to go to the live section here and to the chat channel, and then in there you'll find this list, and you'll have the links for each of the live streams. I opened this Colab notebook from here, so we can see that it's working now. And again, I'm gonna move myself shifter to the middle of the screen. Okay, yeah, thanks. I don't really know why this keeps happening. Oh no. Yeah, so this is the Logitech Brio. I don't understand why this keeps happening. So if you have any solution for this, this webcam. It has the camera settings app, and even though it helps you customize a lot, it keeps changing the settings every time that you open different applications or deactivate it and activate it. So yeah, okay. Thanks for letting me know. I'm gonna go to the right now. Thanks for letting me know again. That's really important, and probably I should keep my my preview here on the left. I'm just trying to save some resources. All right, so let's go to the title slide here. Right. Hi everyone, it's Nono here, and we're gonna see how to train a StyleGAN 2 model. We're gonna do this in Google Colab. We already have a Google Colab notebook that we prepared on livestream number 23. You can also see more information about StyleGAN on this livestream. This is livestream 24 or livestream 18. So let's get started. Okay, so we have here a notebook that contains already code. Well, this one is a notebook that we saw last week. Is not the one I wanted to open. Okay, so this is public notebook. Okay, we're gonna close this one. So I guess we'll edit this thing here. All right, let's see. Predict Colab notebook, StyleGAN training Colab notebook. Okay, this is the right one. Cool. Things of live streaming, errors. All right, so this is it. We're gonna open it here, and this is where we are. All right. Not sure what's better. So if it's better for me to be here or here, probably here. Okay, so this is the notebook, and we're gonna go again. Hi everyone, it's Nono here, and we're gonna take a look at how to train a StyleGAN 2 model using Google Colab. We have a notebook prepared that we prepared on live stream 23. This is live stream 24, and you can see more information about StyleGAN on live stream 18. I think in that video we used it with Runway ML, and we used checkpoints that we had trained in Google Colab with the interface of Runway. All right, so let's take a look at the actual notebook. So this is the notebook that that we have prepared on Colab, and there is a lot of refactoring from the original notebook that was prepared by Parth Suresh, and I hope this one is the one that I cleaned up. So yeah, let's take a look. All right, you can see on the very left, you can see this table of contents. This is something really nice that Google Colab does for you. So you get those markers or those sections that are actually headers on the markdown blocks of this notebook. So you can see StyleGAN 2 is at the top, is a header level 1. So it's just one dash or one hash. And when we compile this, this is markdown, and we could add new sections here. Section 2, section 4, right? And those sections actually should appear here. I don't know why. Maybe these are, yeah, this is different sections. Maybe they need to be independent blocks. So let's try. Yeah, so that is an independent block, and it does create a section marker. So we delete these ones, and we'll have to put our section title in a separate block. Section title here, and that updates here, and then we can navigate our notebook via these sections, which is really nice to find things quickly. All right, so we'll delete this cell, so I can press in here, delete. Okay, so this notebook has many things, and if I scroll, I would say it's a bit overwhelming. We don't really have the resources or the time right now to understand everything that's going on here. I've tried to explain some of the things on previous videos, but there's a bunch of stuff here. We're gonna try to stay at the top high level understanding of this, and a practice that I like to do is that we're gonna copy this notebook because this is the one that we had on livestream 23 and a bit of refactoring that I did after the fact. We're going to save this notebook as a copy. We're gonna put the date of today, and we're gonna put this is training version 4 livestream 24. That way we have a reference to this notebook that we can reference to, and reference to the other one before, change to anyone from the link, and then we're going to copy the link. And then as a good practice, I'll go here and I'll update the link once again. So this is version 4. All right, so we have that notebook available for everyone, so everyone can access that. Let me know if you don't have access. You can go to the channel and get access there. I did something, I don't know why, but the other day I put my name here. This is like me editing this thing, and I'll just add it here. It doesn't really matter much, but I just want to keep a reference that this one is the one that I've edited. And let's go over the table of contents before we look at the actual code. So first we import the dependencies, right? So we import the Python dependencies for the code that we're going to use. Not all of them are here because there are other dependencies below. We could move them up. We mount the Google Drive. So this is, we have access to a Google Drive, and that way we can load models to generate images from there, or we can save artifacts. This is fake images that the model generates, and checkpoints of the model, which is like the trained models that we train along the way. Then we have some settings. We define the train network to resume training from, in case that we want to use a previous checkpoint, which is what we're going to do, because otherwise you'll take days and days to train. We create the required Google Drive directories. So this is the documents, we have to save them somewhere. And if we set a path and that path doesn't exist inside your Google Drive, the code here creates those directories. We clone StyleGAN 2 from GitHub. So this is like the repository where the code lives, provided by NVIDIA. We download and prepare the dataset. We replace the variables in the files, right? So in this note, let me see what's in this note. All right, so these here doesn't have, so download and prepare dataset. So we prepare the dataset. This is the training loop. So this is define or create training underscore loop.py. And and we have to customize the variables here. We replace some variables, we customize the training variables, and then we generate images. Up to here we're training, so customizing training variables. Then we actually train here. So let me see. Yeah, and then here we will say this is actually train. This is number 2, this is header number 2 as well. All right, and then generate images. The generate images block is big, and I think I do have a separate notebook for this that we would have to take a look at, because here, take a look at the StyleGAN 2 Solar Predict notebook, and we'll do that later. All right, so I haven't really introduced what we're doing, because I assume that you might have been following past videos, and that's something that probably not great on my end. There, as I mentioned, there are other introductory videos into what StyleGAN is, but today we're trying to continue with what we did last week. I even have some summary videos that I have to upload to GitHub. So yeah, you can learn more about StyleGAN 2 on the web, but now we're gonna try to focus on getting a training going. All right, so let's try to run the notebook. Let's go into import dependencies. So we'll go running this cell by cell, but first let's try to customize the settings. So we have here a network snapshot that I'm using. So let's see if this actually exists. Let's try to verify that the links exist. This can be previewed, but it does exist. We have here this dataset link, which are these images augmented. So this is the actual dataset. Great. And that's it. I mean, then here we have the experiment directory. So this is the place in my Google Drive where all of our experiments are going to be saved. So we're going to call this live. And yeah, that sounds good. So let's say live 24 network. So we're going to continue from here. There is a bunch of code that I did last week refactoring on the live 23, where depending on whether we're using a Dropbox link, CloudFront link, or Google Drive path, we process the file and the network path in a different way. So you can take a look at the code if you want to know more about it. So first, we're gonna execute this cell. So this is, we're gonna close, or do we close this? Well, I guess it can stay there if you wanna see it, but it's okay. All right, so let's make this a bit bigger. All right, so we execute, so let's make sure that we have, I mean, if you have Google Colab Pro, which I explained why you should last week, you can select GPU and high RAM. To use TPUs, you need your algorithm to be customized for it. So we click on this cell, it's gonna run, and that's it. Now this one is gonna ask us to authenticate in the browser to give permission to our account to access our Google Drive. So I'm gonna do this on the other window to get like a token code. I'm gonna paste the authorization code on the Colab notebook, and then we can see that that notebook has been mounted. So I can see that it's here. So I have some files here, and then we have the ML folder with some other things that I have there. What we expect to happen here is that this folder here, so this experiment there is content drive, my drive ML, StyleGAN, that doesn't exist, and it will get created later when we create the required Google Drive directories. So we have executed that. Our configuration is good. So maximum amount of images we're gonna use is 5,000. And we're gonna say that we're gonna resume from step 15,082. That's because this model is at step 15,082. That means that we used initially a checkpoint that was trained for 15,000 steps, and then I trained it until step 82 with my own custom data set. In this case, I think it was a portraits data set that I trained from the Flickr faces HQ dataset to portraits, right? And I cannot see that from here, but it's okay. I think that's it. So I click here, so I define all these variables. We could create a cell here and say, okay, what is the value of reassume KMJ? And then we get that, but we don't really need this. Now the network by default is Google Drive, but if it detects that the network actually has the Dropbox path, which in this case it does, it's going to define the variables in a different way. So we're going to click here, and now it's going to actually download that network if it sees that the file doesn't exist already on our notebook. And it's downloaded from Dropbox. We could have copied it from Google Drive or just load it from Google Drive, but if it's on Dropbox or CloudFront, you actually have to download it to the notebook. And now look at this, right? So look that it's only the object detection notebook that exists here, and then there's this ML folder, and we're gonna want to have the models directory, the artifacts directory, and the artifacts save directory, right? You're gonna see what that is in a second. So I'm gonna press play. So we now have the models and artifacts, and then the experiment or the model name is network snapshot 15082. And then when we click here, so when we update or refresh, you can see that the StyleGAN folder shows up, and I can click here. I can see the name of my experiment, which is the date of today, live 24. And then I can see I've created the models folder and the artifacts folder. The artifacts folders contain the name of the current network and doesn't have anything, but here's where we'll save things when we generate images. For now, when we train, we'll just save two models. We just want to save checkpoints and fake images are generated each checkpoint, because that will allow you to inspect the output or like what things a given checkpoint has learned. I can show you, and I just saw that I need to deactivate my Dropbox account for the live stream not to be super slow. But if I go to my models here, so my models folder, you can see that I have the sketches experiment. I have the, this is actually not using that structure, but this one is neither, but I did this after the fact. But this would be the models folder, right? So we have the checkpoints here where you have a fakes image that you can see that was generated with step 5000. This is right when we begin from the Facebook, so the Flickr faces HQ dataset. And as we train with the sketches, you see that that image gets goes fading and fading into something that resembles more and more like my sketches, right? And as you can see, now I'm automating that for each checkpoint. So each checkpoint here, like 49, we have an image. And that way we can visually see what each checkpoint is going to look like, what sort of images each StyleGAN model can generate. So let's go to the portraits one. We have the checkpoints here as well. So here we sort by name. And then, we can get a history from the 86 of sketches we trained, and as we go down, we can see this model changing. And let me actually zoom in. And as I go down, you can see that it resembles more and more those faces. So this is actually a really nice, let me just take a look again. So this is a really nice animation, right? Let's do that once again. Yeah. So that, that's pretty cool, because it lets us see what the, let me see, maybe we can just make this smaller. Yeah. So you can see this is the last step of the portraits model. This is in between where it seems like it's working the best. And this is the original model. So from a checkpoint that I had trained for 86 steps, not 86, yeah, for 86 steps, I don't really understand the steps here. It's a tick or something that is called. It goes and changes up to this, right? All right. So now that we've seen this, that we understand what's going on, so why we've created these things, and I forgot to show you the artifacts folder. The artifacts folder is a folder in which maybe not here, we're gonna see it later. Yeah, so here, this is a structure that we're gonna use now. So we have the network name, and under the network name we have videos and images with the network name, and then the random seeds, or the seeds that we've chosen to generate each of the interpolation images on the latent space, right? So we can do that with images that look like this, right? And in here, you can see, if we zoom in here, so we can see 5, 1, 18, blah, blah, blah. These are seeds that we're inputting model or network snapshot 015, 15, blah, blah, and obtaining these things. And then from that, we can generate an interpolated video and do something like this, right? So the network creates a latent walk video and goes from image to image, each of those seeds. And what I want to highlight here is that we have a really good way to trace our experiments. We have the artifacts folder, and then inside of artifacts, we have the model name. So this is the checkpoints that if we go to, 1535, right? I could go back and say, okay, let's go to 135. So we have this checkpoint, right? So we know that this model, so this file that is 380 megabytes is generating these images, and we can reproduce that if we were to get that model loaded into our notebook and then input these seeds, these numbers, so 477, 475, 465, blah, 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 into the generate images section that we have here. So if I show you quickly, you can see there is some part where, yeah, it might not be here. I think that's in this link that I have here. So in this notebook, to generate the images, we do have that list, right? So this is a list of random numbers, but we have those lists. And actually, this is probably the last experiment I did, 5, 1, 18, 78. And that was in here, right? 5, 1, 18, 78, 92, yeah. So this image was generated, or this video was generated from there. All right, great. So we've covered some ground, and we now understand what's going on in this notebook, right? So we've created the directories. Now we're gonna clone the StyleGAN repository. You can see it's from NVIDIA Labs. It's a StyleGAN 2. NVCC is testing that these things can run. So this is a CUDA custom program or custom operations. And we're cloning that, so that's there. We now go to the content directory. We can now see that StyleGAN is below here. So we have all the repo, the code of the repo. And now we're gonna download the dataset and prepare it. There is a process here that takes a bit because it has to create a set of TF records. So we have to verify our data, process it, and then generate a set of TF records that is the type or the format of data that TensorFlow uses when you create one of these data sets. So this is now downloading. We will now run this cell. This is going to check or verify that all our images are valid. We're going now to resize all the images going to the max dataset image. This means that we won't process more than 5,000 images. This is a hyperparameter that you can change on the settings. So you can go here, and this is like this parameter. We're now in download and prepare dataset. We're going to run these things. And then we have this dataset tool.py. This is a script or a program that comes with the NVIDIA Labs repo and StyleGAN 2 that runs the create from images command and then gets the images that have been unzipped here and creates a dataset there. That dataset is pretty big. I think files go like, I don't know, 15 or 20 gigs of data. And then we'll go back to the training folder, then create a training loop, and then start training. We have a few more parameters there to customize here on right here, right? Like where are we getting the data set from, the config ID, the total steps to train until, and some other things, and where we're gonna save the files. I don't worry that much about where the files are saved because I'm also copying them to my Google Drive, right? On this train block, if I look for Shutil copy, I'm actually taking those fake PNG images that are generated and the network snapshots, the PKL, so those are the pickles checkpoints. I'm copying them to my Google Drive, right? So this is some code I added last month, and that works already. There was some magic trickery that I had to do here in order to convert or like edit the it's kind of injecting the variables of the model directory and some other things into here. So they resume what checkpoint we're resuming from, how many K images we have on the hyperparameters, and the directory of the models where we want to copy to. And those come from above, let's say from above the notebook. And we had to, or I had to last week after the live stream, I kind of broke my head a bit and had to use this command line thing to replace those that template that I put there with the actual values, and I actually had to escape the path and stuff. But you don't have to worry about it. As long as this shows up properly, then you will be able to train correctly. So I'm wondering here, so what we're going to do is something similar to what we did last week. We're going to train, and we're going to just see the model there. We're going to see the checkpoint, and then we're going to go straight into creating images, right? Generating images from that model. And, the only thing you have to think about is that StyleGAN it took me, I think, 8 hours to get good results, or 6 hours to get good results with some of these data sets. The one that is on this notebook you can use is the one with the sketches, and we will just train for a few steps and just see the checkpoint that is saved. That will be really similar to the one that we have initially, but then we'll try to use that to generate images. That is the second part of the live stream, that if we don't cover today, we'll postpone it to the next live stream, as always. All right, so the data is being prepared, and what I mentioned to you before is we have this custom folder here and this datasets folder, right? So the custom one, we've processed all of our images. If I open one of this, I think I can double click here. Yeah, this opens here, and this is one of the sketches. If you can see, I'll close. You see, it's just one of the sketches, and the datasets folder, if you go into here, you see these are TF records that are being created here, and I believe these are quite big. Like, I tried to download these ones to not have to go through this process over and over every time I run the same dataset on StyleGAN. But then I discovered that while my dataset is like I don't know, like 100 megabytes or 50 megabytes or like nothing too big, these files get up to 20 or 15 gigabytes just because of the nature of how the TF record dataset is built. Don't ask me what it does. I don't know exactly, but it just does some data processing and prepares the dataset for training. So once this finishes, we'll be ready to train. So let me pause for a second and ask you if you have any questions, any thoughts, or anything that you would like me to try maybe or explain. And feel free to put it on the chat on the Discord server, or put it on the Google, so on the YouTube chat or the comments. All right. Let's see, this always takes a bit of time. Cool. All right, let me grab, while this is getting done, let me grab quickly some water. All right. My fault. Okay, I'll scroll back a bit. Audio is back. That's my fault. This happens sometimes. I have to say. Thanks, Kieran. That was super helpful. Otherwise, I would have been talking by myself for a long time. All right, so let's recap a bit. And what I said is we were in here. So we have here. So the data set, the TF records has been generated. So there are 9 files. And hello. Yeah, there's audio now. It's a bit laggy, but thanks, Kieran. Thanks, Sujay, for letting me know. This is really good. This is really helpful. So we have added 158 images to the TF records. So we have 9 files in the TF record here. If I were to download this is huge. It's like gigs of data. That's why I don't save those. I just save the original data set. And if we now go down, so we go to this create training loop, we execute this file. So we rewrite the training loop file with all of this code exactly as it is. And note that I have here some hyperparameters that are to be expanded. So these variables are not set. These are just some templating syntax that I used. And if I go to the next cell, so we've already executed this one. So if I go to this next cell, we can see the hyperparameters, so our network path, our resume k img, and the models directory. So this is good. And now you can see that when I run this cell, what happens is that these 3 lines get replaced with these 3 lines. So we're expanding the resume pkl, kimg, and the models there for their original values that we've set up top as hyperparameters. We can see that here on the settings. So we have network, we have resume img, and then the models there is being defined in here because that's, that's a hyperparameter from the experiments there and the word models. So when we go back here, we already created a training loop, we replace the variables with set, and we now customize our variables. So I was here when I realized there was no audio. I would stop for a second. Thanks so much, Kieran and Sujay. Being there live makes this a lot better for me, and also that you helped me avoid recording something that makes no sense because it had no audio. So thanks a lot, and let's keep going. All right, so all right, so we have this customized training variables block. This 50,000 number, right, the total KIMG is the amount of ticks, I think, as it's called, or steps that we're going to train for. If we look at the models I have there, I believe, I'm not too sure, I don't know how far that will get, but I think these checkpoints were originally trained up to 15,000 KIMG, I believe. And I trained for 86 more, or I'm not sure if it's 86 or 8,600. I'm not sure, but we're going to try right now. So what I mean with this is that if we put here 50,000, that would be a really long training time, right? That 50,000. If we look at this file, right, on my own experiments, we have this README file that if I open it on Visual Studio Code and probably make the font bigger so you can see it, you can see here, this is me saving the output of the training block to make sure that I can, I can refer back to how a model was trained. So you have these ticks here. So if we tell it to train for 50,000 KIMG, this is what would happen, right? So we're training, and then we can see that the KIMG goes from the original 86 to 86.1, 90.2, 94, blah, blah, blah. And then we get up here to 15,200. You can see that the process with these GPUs took 7 hours for 200 KIMG, right? So that's like thousands of images. And that's not something we're going to be able to do right now. I guess like what it makes sense for you to train for is something like, I don't know, 100 or 300 KIMG, thousands of images. And right now, as you can see, it only takes 70 minutes to go from 86, like this is like 4 or 5 KIMG, but it takes to go to the next one, it takes 55 seconds. So we're going to just make a test because we can, and we're gonna put here KIMG, just 1, and we're going to try this. So originally this was 50,000, but it would make sense to use something like, to use maybe like 100 to 500 or something, depending on how many hours or days you want to train for. So we save this and then we run this training block, right? So there are some things that are being defined here for the model. We're not going to touch it right now, and we're going to run it. So everything above here has run. We've executed in this runtime, importing the dependencies, mounting the Google Drive, setting up our settings or hyperparameters, defining the train network that we want to use to resume for training, created the required Google Drive directories. We've cloned StyleGAN 2 from GitHub. We downloaded and prepared our dataset. Our dataset in this case was in Dropbox, and then we prepared it with a custom StyleGAN 2 script. And then we also downloaded the network that we want to resume from Dropbox. But this notebook also allows you to specify a path in which you have your model on Google Drive or in CloudFront if you're going to use some of the originally provided checkpoints that NVIDIA StyleGAN 2 provides. Then we create the training loop file. That's something that is to customize a few variables. We replace with a command line argument program that is called set. We replace or expand a few hyperparameters that we have here on the notebook. And then we customize the training variables, mainly choosing the KIMG steps that we want to go for, and then we train. That's what we're doing right now. You can see that the model is starting to set up. So you can see here all the different layers of the model: convolution, skip networks, conversion from RGB into a tensor, and the last one is the output or the dense model. Not going to understand the network or the architecture of StyleGAN right now. It's really complex. And now we're building a TensorFlow graph, and this will start training. After it starts training, the first tick number 0, will take 1 minute or so. And that is what we were taking a look at here. So you can see that this output here that I already have is exactly the same that we're seeing on Google Colab. What you can see is that we will build or start building the TensorFlow graph, and then we will initialize the logs and then start training for the amount of KIMG images that we've set. Tick 0 again will tick after something like 55 seconds, and then each tick will, I think, exponentially take longer. I don't know. Let's see. So ticks here, so this is 6 plus 10, so 16 minutes. This is 17 minutes. Yeah, it's more or less 16 or 17 minutes per tick afterwards, after we pass a certain threshold. So it's 17. Yeah, so let's say every 17 minutes our model is going to tick, and it's going to execute a code that is set up on this block before, that is going to actually save a checkpoint. So that's a set of so it's like a pickle file that contains the state or the knowledge of the network at that point in time. So that checkpoint gets saved there. They're up to like 380 megabytes each. Yep, and also an image with the fakes. Those fakes are this. So these are synthetic fake images that the model is generating at each of those ticks, right? So we have 131 and 131. And if we take a look at this file, that gets saved from the Google Colab notebook every time the model ticks. So you have to account that for the account that you have and the folder that you have, if we left our computer running for 7 hours, saving at every tick, we're gonna have, in this case, 29 checkpoints that are gonna be 380 megabytes each, right? So that makes for 11 gigs of data just with those checkpoints. So you need to decide, maybe you put some logic that the checkpoints are not all saved. Maybe you save one every 3 or 4, or maybe if you have like a Google Drive account that is, have a few terabytes of data, then you don't have to worry about it. In my case, right now I have 30 gigs, so this is no problem because I can train for maybe for a day or something and be more or less fine. But yeah, so that's the idea, right? So let's go back to the notebook. Let's see what has happened so far. And what we can see here is that this has executed already. We told it that we're going to train for 1K image, and then we finished training. Let's see what happened, right? So we have trained for just 1K image, and maybe because what I can see here is that this was training for 1 or 0.1, so we didn't really get to tick at all. And I don't really know if I have a way to see where we had started with this experiment, but probably it's not at 86. All right, so it seems like nothing got saved. So we're gonna increase these up to maybe 10. So we're gonna save that and then execute the training loop again. And what I will do now is I'm gonna open on a different browser just to put it here in a second. I'm gonna open my Google Drive folder, and we're gonna see for the account that I have authorized access from the notebook, what was saved, if anything, right? So we have this folder here that is containing the StyleGAN folder with that Live24 experiment folder. And let's see, what do you think? Do you think there's gonna be something on models or not? I think we're not gonna have anything, but who knows? Let's see. All right, yeah, so there's nothing yet in there, and we'll have to wait until the model ticks, and it will save both a checkpoint with, the little span of time that is trained and some fakes, which will be virtually the same as just generating images with this model. And, if you wanna see how to prepare your own data set and train, right? Or like what checkpoint to use to start from, you can go to the livestream 23, to the previous video of last week. We do have something different right now that is using a checkpoint that I own, or that I trained on my Dropbox account that is shared publicly. But you could also go up to, you could go into the StyleGAN 2 website. So the repo, and just look at the checkpoints. So let's zoom in a bit here, config F, right? So networks, if we go here, yeah, so these are the pre-trained networks, right? So you can see that some of them, they're like around 300 megs, I think. And I think I trained from this one, from the Flickr Faces HQ dataset. So Flickr Faces HQ. This is the NVIDIA's dataset of faces. You can see here, it's StyleGAN. Yeah, so 273 gigabytes for the TF records for StyleGAN, with the entire dataset of Facebook Flickr faces. You see the number 10 is 205 gigabytes, and that's because it probably contains an immense amount of images, and that knowledge that is extracted from those images is 70,000. What is this? The wild images, original images from Flickr. So there's the Flickr Faces HQ is a dataset that contains 210,000 images, and the size is 2.5 terabytes. That's 2,560 gigabytes. That's huge. And in that way, I guess the TF records is smaller, so it's 273 gigs. So it's a lot smaller than the original. And yeah, so in the wild images, I don't really know what this is, but you can explore the different data sets that these guys have tested with or trained with, and the metrics, right? So we look at this as a gallery. What is this? Yeah, so these are images from Flickr, probably images that contain a license that allows for the use that NVIDIA gave it to it. And you know that Flickr has thousands and thousands of images, so these are just images that NVIDIA could use for this purpose. And yeah, these are like 180 resolution images. Yeah, okay. So this is just a bit of background on the data set and the trained model. So this is just to say this is on NVIDIA, and I don't really know how I ended up with the link that I have. So I have a link there, 10K image. Right, so we might have to just go, maybe this is, you know, this is actually, this might be one, and maybe we put 10,000. All right, let's put that there. So I put 10,000. I'm gonna go above and look at the settings, because I see something that it might be conflicting. So this CloudFront.net, I think this might be a mirror for the URL that I saw from NVIDIA. Let's see, let's verify that. Yeah, so on top of this domain, so on top of this URL, so NVIDIA has this subdomain, so MVLabs, so these MVLabs FI CDN, nvidia.com, StyleGAN, right? So this app, so whatever application this is, which is just to serve the NVIDIA models, right? It's is this application in CloudFront. I don't know how I ended up with this one, but I think it was on the original link. So if you want to get any of these paths to train from on your application in the Colab notebook that I'm providing, you should not use this domain, but this one. And maybe that's something that we could do. Let's actually do it that way. That way this is gonna work better. Right, so what we're gonna do is that network name is going to be equal to network name replace, and then if we see this domain name, we're going to replace it with this one, which, you know, I don't like, is HTTP and not HTTPS, but whatever. I guess we could do the other way around. We could put the save domain in here. You know, but I'll leave you to that. I think that this is good enough and this should work. Yeah, okay. Let's go down. Let's see how this is doing. So this is now training. It seems like maybe this is doing something more. All right, so this building a TensorFlow graph. Okay, how's it going? For those of you who are online, do you have any questions so far? Do you have any doubts? And what I have here is the second part is like how to generate images with StyleGAN. All right, so I'm gonna record 2 cover videos here really quickly while that is training. Hi everyone, it's, well, 1 second, so let's try to do it this way. Hi everyone, it's Nono here, and this is a video about how to train StyleGAN in Google Colab. We're gonna see how to use our custom dataset and checkpoint to train with a notebook that we've prepared on Google Colab. All right, and this one. Hi everyone, it's Nono here, and we're gonna see how to generate images with StyleGAN in Google Colab. This means getting a checkpoint or a trained model that we have already of StyleGAN 2 and using a custom notebook in Google Colab to generate images from the latent space and also to generate latent space videos. This means interpolating between different ways or different points or places on the latent space of the trained model. Okay, so that is those are the covers, and this is what we're gonna take a look at next. And again, not sure if today or the next day. And let's see. Training for 10K image finished. Oh, okay. Okay, so my fault. So I know what's happening. So I just realized what's happening. So we're telling this model that we have an initial model at resume KIMG, right? So resume, this is something I hadn't done before. So resume KIMG is at 15,082. If we tell the model any value lower than this number, and let me, while I'm talking, so let's do, so resume KIMG plus, let's do, I don't know, let's do just 10 to try it while I explain this. All right, yeah, so let's get back at trying to understand this. So we have a resume KIMG at 15,082. That means that the checkpoint that we have pre-trained is at that step already. 1582. If we tell on the customized training variables, if we tell Google Colab, if we tell Colab that we want to train up to 10 KIMG or 1000 or 1, that number is below the resume KIMG value that the model is already trained at. So the training loop is going to understand that we've already passed that number and it's going to stop training. So it's actually not going to do any training at all. Not going to save any checkpoints, any ticks or anything. So what we have to do is to set any number of KIMG that is above the number that we're telling that we're resuming from. Does that make sense? The resume KIMG only makes a difference because it's the number that this training loop is going to use to save future checkpoints, right? So if you start from 5,000, train to 5,300, then the next day it's going to name from 5,300 and above as it trains new steps. So now this theory, right, this explanation that I just told you, hopefully it's true and we can see that the model actually starts training. So we're once more creating the TensorFlow graph. And what we're going to do now is that we will save the checkpoints for each of the ticks. All right, so I don't see any comments, any questions, so we are probably going to wrap up soon. And you understand this thing of the StyleGAN checkpoints in here. And this there is some information on there, so I'm gonna put a reference to this on the channel as well. Right. Right. So there is nothing yet on the models folder on my Google Drive. And that will hopefully happen soon. All right, so I still have some time. I don't have too much time, but I do have some time, so I'm gonna take a quick break. I'll let you with this screen while this is happening, and we're gonna see some checkpoints soon. And what I'm gonna do is we're gonna take a look quickly at how to generate images, gonna try to copy the code or at least understand the code that we have there, and we'll continue from there next time. All right, so this is now training for 1592K image. This is what I told it, right? So we are starting at 1582, so we're adding 10, so we're training for 10 more K IMG, and that seems like it might do something. All right, so I'm going to disappear for a second while this is training, and I'll be back. And again, hopefully I get the audio back. Tell me if it doesn't get back or I don't plug it back when I'm back from the quick break. And feel free to put any questions on the chat. Oh no, haha. Okay, errors. What's happening here? That is not something I was waiting for. All right. Oh, man, when allocating tensor on type float on job by allocator, blah, blah, blah. If you want to see a list of allocated tensors, all right. Oof, what's happening here? Okay, I didn't expect this. I don't know if we're not running out of RAM, so this doesn't make a lot of sense to me. RAM used, GPU used. We still have some RAM, so okay, so let's take a look first that the code hasn't changed from the last time that we saw it. All right, so a link. So this hasn't really changed since I last trained it. So it really shouldn't have failed here. Resource exhaust error. All right, so this might be we've tried to train on the same machine many times. Your GPU is running out of memory. All right, so it doesn't seem to be like a big problem. So what I'm gonna do, I'm going to restart the runtime. So for that, I'm gonna go, right, so don't panic. Okay, so we have here this button. So we go to RAM and disk, we click it, we see the active session. So this notebook is here. We're gonna terminate it because are you sure? Terminate. All right, so we terminate that. Hopefully it doesn't lose track of our files. So Hopefully we keep everything here, and it seems we do, and we don't have any active sessions. So now we have to run all the cells, but I'm gonna be careful connecting to a runtime to enable file browsing. So we might actually have to rerun everything and reconnect here. All right, so as you know, this is what happens in Colab. Your memory is not persistent. So I'm gonna just go and click here and click on run all, right? So we're gonna have to wait for some of the things that we already waited for before. This is a bit boring, but because of the nature of what we've been doing, we've been trying to train like a huge model multiple times on the same instance notebook, and that has made the notebook overload in terms of its resources regarding the GPU. So now everything's okay. Network name is not defined. All right, so this should be network. You see how coding in the wild doesn't really work. Yeah, so where are we putting CloudFront? So just here. So maybe we can do what I said before. So we have that there, and we could do it the other way around. So we're gonna put here this thing, and we're gonna put NVIDIA, and we just need to swap this with this. We're not gonna test this code now, but hopefully that works. And that should be it. CloudFront. Yeah, so the only thing I'm trying to say is here, instead of that, we could say that this link is this one, right? Yeah. All right. So we'll leave this like this, and we're gonna run all again. Right, so we're downloading the network, and you know the part that will take some time is that we need to rebuild the TF records, but you know everything seems like it should be working now. So while this is being done, because I'm gonna have to leave soon, and we're gonna take a look at this other notebook. So this is the Predict notebook. That is a separate notebook that I used to generate images, right? To generate images from the models I already have trained, or models that are out there. So you can use checkpoints from anyone. You still have to download StyleGAN, and you need to also mount Google Drive. And I'm just trying to see what we did the other day, if there is a lot of code that is repeated. Okay, so yeah, this is like a really simplified version of the other notebook. Okay, so okay, so these okay, here's where I put my name. Okay, so this is gonna be okay, so we can maybe point to this other notebook. All right, so we put a pointer here, so we still download StyleGAN as we did before. So download the code. If you want to store files to your Google Drive, run this cell. So yeah, this code I already have on the other one, so we probably don't need it. And we download the network. Yeah, I'm doubting if we should have two separate networks, so two separate notebooks, or if we just should use the same one. There is code below here. And the only problem is that if you want to run the notebook quickly, the code that I don't want to be on the other one is the training code and the dataset preparation code. So maybe let's just copy the cells up top, and maybe we do this. So we do here. So what is this? Okay, and I'm just going to be copying here the sections. So import dependencies, and we put here these things, and now mount Google Drive, and now we put here this code. Settings, so we need settings as well, and we put here, I'm gonna put the same thing so far, because we do need the network, we don't really need the data set or these things, right? Great, okay. So now we define train network to resume from. To generate images with. Great, and now we copy this code, put it here. Great, and create Google Drive directories if they don't exist. Yeah, and sorry, this is refactoring code. This is a bit, it's a bit less interesting, but it's gonna help us a lot. So this is clone StyleGAN from GitHub. We wanna make sure that we copy to the right place. So we're gonna put this here. And that's it. And now after that, I think, we don't need to prepare the data set. We don't need the training loop. And I think everything below is good. Customize training variables, we don't need that, we don't need to train, but we do need to generate images. So we don't need this, so artifacts there, or print there, save there, and here we don't really need any of this, so we're just gonna say that saves there. We're gonna have to change it. Yeah, models there and artifacts there, that's something that we're already defining here. And then this artifact saved there, which we're gonna copy and look for saved there appearances, because we need to put artifacts saved there. Save there, save there, save there. And let me make this big while I edit. So artifacts saved there, artifacts saved there. Yeah, and I think that's it. So I'm just cleaning up this notebook. It's a lot of stuff and it's not easy to understand. But the good thing is that we can, in parallel, we can try to generate images, even if we don't have everything. All right, so this we're gonna put here StyleGAN predict, and this is live 24. So we know that this is the one we cleaned. Runtime, run all, and we're gonna download the same checkpoint that we're starting to train from the other notebook. So let me just take this here again. All right. This token thing is a bit annoying, but it makes a lot of sense because it's sensitive. Like in this case, my Google Drive is empty. But in your case, you might use it to store sensitive information, and you might not want anyone to be able to mount it on their Google Colab notebook. All right, so first here, we're downloading the checkpoint, 380 megabytes from from Dropbox. So that's here already. So now we create the required directories, which already existed, so they're not going to be created. We have cloned StyleGAN, and now we customize the training variable. So we load the model. So we're loading the PKL network that we have, and the model is being loaded into memory. So there's a pickle file, we load it, and then we have a StyleGAN model we can use to create artifacts and generate images with that model. After that, we need this code, useful utility functions, and once that's done, so we have utility functions like generate these from seeds, generate images from seeds, save images, image show. We have many utility functions here that will be defined when this cell runs, and then we can start generating images. So we define a set of random seeds that is happening right now actually, and we show the images here. So we have this image show function, and yeah, so that's working, and it's pretty exciting because it's the first time on this in today's live stream that we're seeing some images that are generated live. We have a few seeds here that we're generating more images from. We have here a cell that is generating a video right now, and after that video gets created, it gets copied into Colab, I believe, if I don't remember wrong. I think this also saves to Colab, but yeah, I might be wrong. Yeah, so frames there, save. Yeah, okay, so frames there, join. So we're saving to the frames there. And yeah, I don't really know. I mean, we need to see. Okay, so we're creating the movie at the artifact save directory path. So all of these things that are being created here are being saved to Google Drive. And there will be a point here where the projection code fails because the projection code doesn't work yet. But yeah, we'll work into that. That's also a really good experiment. So that's StyleGAN to projection or projector. This is a really cool feature of StyleGAN where you can input an image, any image. It doesn't need to be on it didn't need to be on the training set. And once what StyleGAN does is it tries to look on the latent space for an image that looks really similar to the image that you're inputting. So you can see here the image on the left is a manga animation movie image, and then the one on the right is trying to project images that are inside of the StyleGAN model with the different parameters of the Z vector that is the input of a StyleGAN model. And from this, it's going to what we saw before in projecting that image, right? We have another example here. Can we convert this lady, this synthetic lady, into Pikachu, right? So it seems like we can't. I don't know if there's something else there, but yeah, it seems like there's some features that are showing up. I don't know. This looks like black magic to me. Yeah, and then as we go, it seems like something is getting generated. Yeah, wow. I don't know. This is pretty cool. All right, so yeah, that's an overview on the projectors. I haven't got to run. I haven't got that code to run yet. And then here, these are more images being generated. And then now, after we've generated, this was pretty soft, right? Like we could get it running pretty quickly. I think we still need some time to learn how to use this notebook because I cleaned it up really quickly, and I don't really expect you to understand anything there. Let me see. Okay, so we have this here, and so this is the StyleGAN to image generation Colab notebook. All right, so that's there as well. And so this is the image generation notebook. We've left the one training aside for a second, and hopefully that's working. Yeah, it seems like it is. And now the interesting part is we will go to Google Drive, models, right? So now we have this StyleGAN experiment of today, and then when we click, we see artifacts and models. In models, we see what we can expect from the training process, which is checkpoint 82 is like saving right when we start training. And then we have this network snapshot. So the snapshot is a set of synthetic fake images that have been generated from that model. And this is exactly what I had before. It's really similar to the images that we saw before on the model. So if we go to model 82, yeah, we don't really have it, but if you look at this one, right, if we compare, it's almost exactly the same image. I mean, they're different because one is 73 and the other one is 82, but it's the same image, right? We've generated the same image, and that's the checkpoint that we have here. And if we look at the training notebook, right, so this is the actual training process, we can see now here the first tick that took 1 minute 17 seconds, and we're aiming for 15092, which would be like 10k IMG. And I don't really know how long it will take, but after 17 minutes or so, we saw before that we will get tick number 1, and then we'll go back to our Google Drive and see that that's being saved in there. And all right, so that is working. Let's try to now understand what's happened with our artifacts. So if we go here, we created the artifacts folder. I mentioned before why, because we want to also save things that we've generated with each of the models to a subfolder. The subfolder has the name of the checkpoint. So this is just the checkpoint without the extension. So the checkpoint name without the extension. We click here, and then this is, for me, I think this is awesome. So we have the different artifacts we've created. So for example, we have here frames, and we have a set of frames for a video. And here we have the frames for a specific video as well. And then here we have videos, right? So if we play this video, we're going to be able to see, so this is an interpolation of the latent space, right? And this interpolation we just created with a model that we loaded from Dropbox, and we defined on the notebook, and that is what we're getting. One thing that is cool that we can do right now, and let me try that just to see if it works. We could go to the predict notebook, and we could set this network path to one of the church config ones. So we copy this link, we set the network to that link, and then I'm gonna run everything again. So again, this is now going to try to process the file. It's going to realize the file is not here, and it's going to download it. So this is now church config F. We'll get a subfolder on the experiments folder in Google Drive that instead of network snapshot blah 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 will be called config church config F, and that will happen, I think, yeah, when we run this create required Google Drive directories folder. And that's what we've created that code for, and we'll see it in a second, or now. Yeah, so that should be created now. Yeah, so now we have the StyleGAN 2 church config F, which is the name of that checkpoint. And here we're gonna get the artifacts when StyleGAN is already there, and we're going to now load that model into memory. And as you can see, we're generating churches right away. What this notebook makes really easy is that once everything's set up, the entire process just runs. You just change the URL or the path or where you want to load your checkpoint from, and everything is done automatically, even up to the point where you can see that the videos are being saved in there as they are generated. And this is really nice because now we can iterate really fast, and we just created a church interpolation video Sadly, as you can see, this one is low res, so this is maybe 256 or 128. It's not 24 by 24 like the other one, but you've seen how fast we were able to create these videos. And yeah, so I'm gonna take a look at the other models. So this still hasn't ticked again. And hello, Bea. I can see that Bea just connected. We're almost getting finished here. And okay, so let me look back. So let's see what this is here. So if we go to StyleGAN too, and we go to this repository, you can see that I think somewhere it should tell you the resolution, right? So for the faces, so for the Flickr Faces HQ dataset, they're 1024 by 1024. I think that's the one that has the highest. And we could pick this config F that we have. Actually, we already have it there. So we have it right in here, and we could put it there. And now we could run all and let it generate, right? So that's going to generate or download the model and then generate videos as we have with the other models. And once again, we can see here that we now have a new directory for that model, and here's where those artifacts will show up. And all right, so I can see that there's more people joining now. We're almost done, but I want to say hello, and I will invite you to write comments on the Discord server or here on the YouTube comments. All right, so we're almost done. Let's see. Where is the training notebook? All right, not ticking yet, but it seems it hasn't crashed, so that's good news. How long has it been since we last ticked? It should be like a few minutes away. All right, so we're saving now images from that synthetic set of faces. These look really realistic. So these look really realistic. This one is even a bit scary. And now we'll get a video composed by, going through the latent space from each of those seats to the other seats, really smoothed out. So let me actually just download this one so we can put it full screen. All right, great. So yeah, and this is the latent space interpolation, which is a bit scary. But you saw how fast we did that, and it's really easy to get a model trained and then get that there. So for me, in this case, right, if I wanted to get one of these models here and we get one of the ones that seem to be better, I guess that would be one of these ones. So I could get the, yeah, I guess I need to get the URL from remotely. Let me open Dropbox here. All right, so I'm looking for the checkpoints. I'm gonna copy the link, and I'm gonna place it on our prediction notebook. So we're gonna put it there on here. So this is gonna be sketches, and this is gonna be portraits. So network, right? So once again, so we run all. This is trained from the 1024 by 1024, so it's also going to generate 1024 by 1024 images. And one thing that we'll do next week as we continue understanding, or we start to understand this notebook, is that we're going to be able to cherry pick between which images we jump when we generate one of these latent space video interpolations. All right, so that is there. Hopefully we now have a new tick. All right, something changed here? Not yet. Why is that? Why is it taking so long? Maybe. All right, so it seems like the generation notebook is slightly faster, so that probably already generating images here. Yep. And we're gonna see the results on there, right? So now we have a new thing, and probably I should name these network snapshots slightly differently in a way that we can know which experiment they belong to, because when you're generating, it doesn't really matter the experiment name, but when you're training, it's a bit different. All right, so we just created this one, so we have images here. So these are images that have been created. You can see from there's this kind of weird portrait faces, and we're gonna watch that video. Right, ready? Right, and the important thing to see here is that we're going to distinct places on the latent space on the StyleGAN model, and the interpolation happens because there's like an interpolation from the z values that we need to input to the model from one image to the other, and we see these kind of smooth out transitions. And there is like two ways to do this. One is on the W with W space, and the other one, I don't know what it is exactly. So you see these are the distinct points on the latent space of this model, and we can generate with this from Z's or from W's, I think, which are two different parameters of the model. And for the W's, it takes a bit longer. There are more frames and it's smoother, and we might have the video there already. Yeah, so this is a bigger video. It's from W's instead of Z's, and we're also going to watch this one. So this one's here, and it's exactly the same interpolation, but so from the same images, but a lot smoother than before. Yeah, and I think it's pretty impressive. You can move it faster, and it's a really nice interpolation. You can see, the features are being interpolated. Like here, for example, there's no beard, and then there's beard here. There's short hair, white hair into like peak hair. Yeah, so I don't know. I think it's pretty cool. Okay, we'll learn more about this. And these tick seems like it's never gonna happen. I don't really know. I'm gonna, we have some reminders here that have to do with add the checks to the thumbnails and schedule next live stream. So I'm not gonna do that today. So I'm gonna, I'm actually gonna think if there's gonna be a live stream next week. I'm not sure yet, but we'll do that. We'll do that offline. And also, I hope that, as we saw at the beginning, I hope that you like this new animation that we made. This is gonna be the starting screen for the live stream, where we can say move, and everything goes up. So that's pretty cool. I hope you like it. And just to wrap up, so let me leave this here for a second. Where is this? Yeah, it seems like it's not ticking. I really want it to tick, so you see that this saves another checkpoint. But if it doesn't, I mean, I guess it's okay. Every single artifact right now, because it ran the same code, was saving one of each of the two videos. And for the interpolation ones, I also saved, and this needs probably better naming, but I was saving the frames. So you have individual steps of the frames that you're interpolating to. And we need to cover this in more depth. But long story short, what's going on is that when I save the video, I save the name, encodes the model that was used, and the seeds that you need to put to regenerate that video exactly the same way, in case you want to change some of them later, or you want to just know how was generated. Do we have a new model? Not yet. Okay, there are no ticks, and I'm not sure why that is. It should appear here soon. So that's the last thing that we're gonna do right now. So we're gonna wait for that, and we will resume next week. Let me quickly see. All right, I'm gonna wait. I really want to see that last checkpoint, but I'll leave this on. I'll come back in a second. We will have our models. So this is the generation notebook that we will continue working on next week. Okay, 1 second. Let me actually do, while we wait for that model, training. All right, let's wait for that. I'll be here. Actually add the checks. And for those of you who are online, I'm gonna stay here for a few more minutes until that gets completed, and feel free to ask any more questions on the chat, or tell me anything. All right, so I think, how do I go here? I know you cannot see my screen right now, but you will in a second. All right. So I said we would not do it, but we are going to do it. So we have here this live stream where we have completed everything, but we can still do some more things. What is gonna be on the next live stream? I'm not sure yet, but this one is completed, so we can save this and update the thumbnail. So this is going to be saved there. We're going to save a JPEG. Yes, and now we'll go to the live stream. It's a bit meta, and I don't think we need to create more images, right? So maybe we actually do the one for next week. So that will be 18 plus 7, so that's like 25, live 25. All right. And we need to choose a random different color. What about that one? So I'm not sure if the theme is gonna be StyleGAN next week. We're gonna put here, I don't know. We'll just put here StyleGAN. And what else? What else do you guys want to see? Maybe the sketch detector. I'm not sure. We need to see. I'm not sure what it's gonna be yet, but we'll see. We'll see. But yeah, I think that's gonna be the color. We'll try that out. Cool. So now we have those two. We just need to go here, close that, close that. Look, this is you. This is the behind the scenes. All right, so here we just click on change. We go to thumbnails, that one, and something really weird. So that updates now, but I need to wait until I get the changes saved message. All right, so we're going to, I'm gonna go here. Do we have a tick? We don't. I don't know. Maybe the first one takes longer or something. I'm not really sure what's going on here, or maybe I set too many few of these ones. But yeah, I mean, long story short, and I don't even know if I put like a, yeah, I put a GPU here. Yeah, so long story short, we would get different ticks here, and after every tick, we will save the model. And that's not happening now for some reason. This might be slower than usual or something, but it seems that we're gonna have to hang up and continue with the day. we don't really know why this is not running. I'm really like thinking we should wait for this, but I don't know. Who knows how long it's gonna take? We don't really get any feedback. All right, so now that's, you know, even though we haven't finished yet, that's now set as done, and that's gonna show up there. So you'll have the entire live stream to watch later, and yeah, hopefully that's, you know, hopefully that's this was useful. How much time do we wait for this? All right, I'm going to drink some water and I'll be back, and hopefully this is finished. Woohoo! All right. Okay, nice. I'm happy that this happened before I left, because for some reason, instead of 17 minutes, it's taking 30 minutes now. I don't really know if I had access to like faster GPUs or what the nature of this thing is. But what we can see here now is that tick 0 was at 15,082, and at 86 we get tick 1. 30 minutes later, and we're getting that each tick it's taking a lot more than we thought, so that's like 28 minutes. And for some reason we were training a lot faster on the other example that I showed before, and we're using 13 gigs of GPU memory. But what this means is that how we've set up our experiment, we would train from 1582 to 1582 plus 10, so 1592, because that's what we've set it up to. And at this pace we can calculate more or less how long it's gonna take in total. So we have 10K image. So let me just remove that edit. So this will say, okay, if we have this per tick, right? And K image. So per K image, so you have 10K image multiplied by this divided by 60, it will be 1 hour and 16, well, which is like 1 hour and 10 minutes to train the entire thing, which seems reasonable. So it's done in 30 minutes. It's done like 4 of them. So in like 40 more minutes, we'll do the entire thing. So with this parameter here, with the second per K image, we can calculate how many, how much time it's gonna train. And the practice is that you train for an amount of time that you're gonna be able to cover. But if not, you can always click here on stop, and we know that each tick is saving the model to our Google Drive in this case, right? But if you didn't have the Google Drive set up, these saves are being saved here, and we have the snapshots being saved into this folder. So we have 82 and 86 here. We have the fakes as well, so we could open this image and see what has been generated. And we can also stop this. I think we click a couple times or stop the we click there, so that gets stopped, and I think it just it just crashes. Well, the exiting respondent, do you like to interrupt, including all local variables will be lost? Yes, so we interrupt it, and then we lose track of our runtime, which sadly sometimes means that we lose the files. But if we don't reset the runtime, I don't think we lose them. So we get these files here, we get the run and the log.txt files. So this is what I was saving before, that I showed you that I was saving. So you get, you see here, I don't know if we get it here. Yeah, so we get some error because we've shut down the execution, and you get the information about your the ticks, right? Like the training time that we've done. Good thing is, even if what I'm gonna do now, that is just put this back to normal size, close these two views, and what I'm gonna do, well, I guess I can leave this like that, but well, with that error, I don't know. And what we can do here is, I'm going to go here into edit, and where is it? Clear all output. So clear all cell output. I'm gonna save this notebook so you can access it clean. You have here the networks that I've been using for pre-training and the data set of the sketches. I guess we could also set here so resume KIMG. I guess the last hyperparameter that we could take a look is this one. So resume KIMG, train KIMG. Yeah, so train KIMG, and we can put that as a parameter here as well. So we can do here train KIMG, and we said 10, but we could say, I don't know, something that might make sense, 200. Let's see, amount of KI-image to train from the resume KIMG value. And then here we can put, what was it? Like around 500 second per K image. And this is, if we put some code here, iGPU, just to get the info DGPU. No running processes. What? Maybe, oh yeah, Tesla P100. I think the V100 is faster. I don't know. There might not be availability. I don't remember now. But yeah, we have a GPU, so and this is approximately. So if we have 200K image by 500, that is like 60 by 60. That's like 27 hours. Yeah, I guess like if we get it to 400, 22 hours. Yeah, I'm not sure how long. Let's take a quick look at the Visual Studio code that I had here before. So we were, okay, so this was a lot faster. So 234 multiplied by, let's say 200K image, or like 100K image, 23,400 divided 60 divided 60, that's 6 hours. That makes more sense. That's what was taking 7 hours here. All right, really quick stop. Shout out to somebody who's connecting online. And I'm just gonna put a cover here while I talk, so I don't talk over other things. Comment from Rafael Igallara. I have to say, it's really nice to see you around, that at least you're checking out the live stream and plugging in. Rafael is saying, hey Nono, I haven't been able to watch your streams live lately, but I've been catching up on YouTube. Thanks for the content you're putting out. It's incredible. I really want to thank you for the comment. Even if you thought that and you said this is silly, thanks a lot for putting it there. It's really important for me. I think if you find it useful and other people find it useful, that's what's going to keep me going. And I'm learning personally a lot. This refactoring of the notebooks and making it easier for myself to use in the future, open sourcing it and putting it out there so you can use it as well. It's incredible because I'm learning a ton. For example, today I've learned about things on StyleGAN, and I hope that people who watch this video now, live or later, do as well. So yeah, thanks so much for the comment again, and yeah, much love as well. And yeah, we can also send me any messages if there's anything that you're working on that you want to share with the community, or anything that you're interested on having me talk about on the live stream in the future. So we're trying to do this every single week. Right. So that was just good thanks to you, Rafael, or Rafael. I tend to pronounce names in English when I'm speaking in English. And so we have the live stream. We're going to wrap it up right now. The last thing, so we've put here the train K image. This is going to be a setup that I use. So this K image in some way can be grabbed by these snapshot names, but I tend to put it manually now because some models don't bring it, like this one, and you have to look it up manually. So this would be, okay, let's load this model that is at 1582, and I'm probably in the middle. And yeah, so this model is 1582, and that's where we're resuming from, and then we're training 200 more. So that would mean from 1582 to 15282, if resume K image is 1582 and train image is 200. Ah. All right, and that's like lowest and highest that I've seen at least. All right, so this notebook is there. The links are on the Discord server. You can use, this is the StyleGAN training, and the other one is the StyleGAN. Okay, so let's put it here. So StyleGAN 2 training notebook, this notebook, and a StyleGAN to prediction notebook. Right, but let's put here image generation. Might be a bit more intuitive. All right, so we have the image generation notebook. So we're gonna copy. Where are you? No. All right, I just want to copy the link. And this is a training notebook. All right, so this goes here. And this is the image generation notebook, and we're gonna add the same block to the top. So this is training, this is training, and this is image generation. All right, so this, all right, I don't, this is good that I've lost track of time. I don't know how long I've been here for, so this means I've been entertained and I've enjoyed this. You have the two notebooks there, so we've let me just save this. This means that I've enjoyed this time with you. It's been a pleasure having some people on the chat online while I was recording all of this stuff, and you've even told me that the microphone was off when it was. So thank you for that. Here, the last thing to wrap up is that, we have both checkpoints. So we have checkpoint 86 and 82. These were the two ticks that we had with a span of 30 minutes between them. This took me some time to understand, but, long story short, this is just a preview of what the model can, or like a sample of what the model can generate for you. These are big images because each of these squares is 1024 by 1024, so it makes a 20 something or 30 megabyte images. And for me, the models are here, the artifacts from each of the experiments are here, and yeah, that's it. So I'm gonna delete these ones because I don't really need them for anything. Those will go to the trash, and then we can delete forever. So that was my Google Drive. We don't have anything else open. I would take this time to also thank Kira and Goya. I see that, you've stayed with us for a long time today and joined the Discord server. So welcome you to the community as well. And welcome to everyone who's recently joined. The last thing, we already did this thing. We haven't scheduled, but I will. I would like to say I'm leaving today. We'll see you next time. And, really, the like on the video is a great encouragement. Do it if you want to support the channel, the work I'm doing here, and celebrate all these learnings. And subscribe if you want to get notified when I go live next, or when I upload new videos. One quick thing, if you get to this point of the video, it's probably too late for me to say, but I'm looking for people to help me edit the content of these live streams and release clips and engage in producing machine learning materials and creative coding materials. If that's your case, if you're interested in any way, join the Discord server, reach me out, and let's talk. Okay, join the community. That's at None of the Masas Discord. This is the Discord server I was talking about, and that's it for today. I would also, let you know that I keep releasing Getting Simple podcast episodes. So I would encourage you to go there and maybe listen to some. Some of them are more technological. Some of them are more like coaching side, art, meditation. There's a bit of everything, and some reflections. The last one is mini retirements that you can listen at gettingsimple.com/44. And yeah, once again, that was me, Nono Martinez Alonso. Thanks so much for being there, and I'll see you next time. Yeah, and thanks, Sujay. All right, so who connected today? Big thanks to Jose Luis Garcia del Castillo. Go to his Parametric Camp channel. He has a lot of really good content as well related to all the things we see here. He's looking at WebSockets lately and many things to create interactive applications. He's a master of computational design. And Kiran Goya for joining today, Sujay for being there and supporting every single week, Bea for connecting online, and Rafael for popping up and giving me a message that made me happy. All right. Goodbye, everyone. And I'll see you soon.